Hello, welcome back. This is volume 2 of chapter 7 triangles, and in this video we are going to discuss ASA Congruence Rule, AAS Congruence Rule, example 3 and some problems from exercise 7.1. So let us start discussing now, and before starting, if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. So let us start now. We'll prove ASA congruence rule. Okay. ASA congruence rule states that two triangles are said to be congruent if two angles and one included side of one triangle is equal to two angles and one included side of the other triangle. In this figure, if angle B is equal to angle E, angle C is equal to angle F, and BC is equal to EF, then we can say that these two triangles are equal. That is, AB will be equal to DE and AC will be equal to DF if two angles and one included side of this triangle is equal to this two included angles and one side of this triangle. Okay. So this is which rule? It is ASA congruence rule. That is two angles and side is in between these two angles. Okay. So this is ASA congruence rule and we'll prove that. Okay. Are you ready to prove this? We have to prove that if two angles and the included side of this triangle is equal to these two angles and included side of the other triangle, then we have to prove that these two triangles are congruent. That is what we have to prove. Here we need to prove that if this ASA rule is satisfied, then triangle ABC is congruent to triangle DEF. That is, if angle B is equal to angle E and angle C is equal to angle F and BC is equal to EF, then these two triangles are congruent. We have to prove that. So there are three cases for this. If AB is equal to DE, that is, case 1 is AB is equal to DE. If AB is equal to DE, that is, these two sides are equal. And here, given that BC is equal to EF, we have taken that BC is equal to EF. So these two sides and this side and this angle is also equal, given that angle B is equal to angle E, which means that two sides and one angle is equal. So two sides and one included angle are equal, which means which rule is satisfied here? SAS rule is satisfied, which means triangle ABC is congruent to triangle DEF. That is, case 1 we are taking AB is equal to DE and angle B is equal to angle E is given and BC equal to EF is given because we have taken ASA criteria. So we have assumed that these two angles, this angle is equal to this angle and this angle is equal to this angle and BC is equal to EF. So if AB is equal to DE, then this side, the corresponding sides AB and DE are equal and BC and EF are equal and angle B is equal to angle E, which means SAS criteria is satisfied, and from that we can say that triangle ABC is congruent to triangle DEF. Now in case 2 we are taking AB greater than DE. Okay, so there should be a point P here such that BP is equal to DE, right? Because AB is greater than DE. So there should be a point P such that this BP is equal to DE. Okay, BP is equal to DE. So we are assuming that BP is equal to DE. And we have joined C to P. Okay. Now consider this triangle PBC and triangle DEF. Here we have taken BP is equal to DE. PB is equal to DE. Then BC is equal to EF and angle PBC is equal to angle DEF. So this side and this side, this side and this side, BP, these are equal, which means two sides and one included angle is equal. That is SAS property. And from this we can say that triangle BPC is congruent to triangle DEF. Okay, so triangle BPC is congruent to triangle DEF, which means angle BCP, this angle BCP is equal to angle EFD, right? Because corresponding angles of a congruent triangle are equal. So angle BCP is equal to angle EFD, right? So if these two angles are equal, then this P should coincide with A, right? Because if these two angles are equal, then this length also should be equal. That is, this P should coincide with A. Thus, we can say that AB is equal to DE. So, this triangle ABC is congruent to triangle DEF from SAS property. So what did we prove now? AB cannot be greater than DE. This AB cannot be greater than DE. That is, AB and DE can only be equal. Now, what is the third case that we can take? AB is less than DE. So, there is a point M on DE such that this AB and ME are equal, right? Now, given that BC is equal to EF, BC is equal to EF, given, then angle ABC is equal to angle DEF. ABC is equal to angle DEF. And we are assuming that AB is equal to EM. AB is equal to EM, which means this triangle and this triangle are congruent. So, triangle ABC is congruent to triangle MEF, right? And that means this angle MFE is equal to angle ACB. So, if these two angles are equal, this M should coincide with D, right? Which means AB is equal to D. So, what did we prove here? AB cannot be greater than DE or less than DE, but it can be only equal to DE. That is, if in a triangle, two angles and one included side is equal to two angles and one included side of the other triangle, then the two triangles are congruent. That is, other two sides also will be equal and other angles will also be equal. Okay, now we'll see the case where two angles are equal. That is, angle A is equal to angle D, angle B is equal to angle E. And one side is equal, but this side BC is equal to EF, but this side is not an included side. That is, this side is not in between these two angles. So, we'll see whether these two triangles will be congruent in this case. Let us consider this angle as x and this angle as y. So, this also will be x and this will be y. And what will be this angle? Angle C will be, since this is a triangle, this angle will be 180 minus x plus y, right? And what will be this angle? This angle will be 180 minus x plus y. So are they equal? Yes, the angles are equal. So will this be congruent? Yes, because this side is in between these two angles. That is, this side has become an included side, which means these two triangles are congruent. So if AAS criteria is satisfied, then also the two triangles will be congruent. Okay. Next is example 3 from the NCERT book. Line segment AB is parallel to another line segment CD. AB is parallel to CD. O is the midpoint of AD. Then we have to show that triangle AOB, this triangle is congruent to triangle DOC. And O is the midpoint of BC also. Given that O is the midpoint of AD, and we have to prove that O is the midpoint of BC also. Okay. First, we'll show that triangle AOB is congruent to triangle DOC. Here, given that AB is parallel to CD, and this will be the transversal. If these two lines are parallel and this is joining these two lines, this is transversal of these two parallel lines, and these are alternate angles, right? So these two angles are equal, that is angle ODC is equal to angle OAB, and these two angles are also equal, that is angle OCD is equal to angle OBA also, right? So we got these two angles as equal, and these are vertically opposite angles, right? So these three angles are equal, and given that O is the midpoint of AD, so these two sides are equal, isn't it? So we got these two angles as equal, that is this angle and this angle, this angle, this angle, and this angle A and this angle equal, and this side. So two angles and one included side are equal, that is it satisfies ASA criteria, which means these two triangles, that is triangle AOB is congruent to triangle DOC. Understood? Now, we have to prove that O is the midpoint of BC. Given that O bisects AD, and we have to prove that this O bisects BC also. That is, this O is the midpoint of BC also. Now, how will you prove this? Since triangle AOB is congruent to triangle DOC, the corresponding parts of congruent triangles are equal. CPCT rule, that is corresponding parts of congruent triangle. So this is OC and OB are the corresponding parts of this triangle, which means OC is equal to OB, and that means O is the midpoint of this BC. Okay, so we have proved that also. O is the midpoint of BC. Understood? In this volume, we have discussed ASA Congruence Rule and AAS Congruence Rule, and we have solved example 3 from the NCERT book in this volume. With this, I am winding up this video. We'll discuss exercise 7.1 in the next volume. So stay tuned. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to press the bell icon to get notifications. Thank you and bye.